Hi, I'm Ryan. I run the cloud department at Agility Robotics. This is Rohan. He runs our data platform team, and we're going to talk about not our robot, but rather how we get data off the robot and usable by our engineers. This next slide basically talks about why did we build the data platform, and there's a long paragraph here, but the quick summary is developer enablement. The goal is to make it easy for engineers to come in, add data they need to the robot, get it out up to the cloud, and be able to use in whatever tool they want in order to basically diagnose issues, evaluate fleet level statistics, or whatever they need to do. So we've got a few topics here that we're going to cover here, mostly what are some of our common data types and where we're getting those sources from, how we actually ingest that into our cloud platform, how we serve that back to our users, and then what applications do we actually use for the analysis. So yeah, data types and sources. The first one that's pretty important for us is telemetry. And so telemetry is basically a way to monitor software performance. So this isn't talking about robot telemetry and getting your control stack export and stuff like that. But this is actually talking about the software performance itself. How do we actually track how long it takes to execute algorithms? How often do algorithms fail? How often are we getting error rates? And we need something that allows us to go from the cloud down to the robot and back up. And we need to be able to track those requests end to end. And so for that, we end up using things like OpenTelemetry because it's a fairly common cloud standard that allows us to see these requests end to end. The next sets of data that we look at are sort of our key data types. So this is pretty much your common robotics things. So you've got all of your sensor data, your diagnostic data, the things that are coming from the control system, things that are coming from the motion planner, and such like that. And so with that, we end up with a few different data formats to kind of help us out. For the most part, a lot of our stuff is using Avro, which is basically a common data format that allows us to use a lot of the cloud native tooling. On top of that, we also use MCAP. That's largely for our perception data. And then we have JSON data that allows us to do sort of human readable data. And we built the cloud data platform in order to ingest all of these and use them simultaneously for whatever we need.
Cool. So this was the proposed end-to-end architecture of the data platform that we started with. A lot of the team's background is actually in building big data cloud infrastructure for social networks and SaaS companies, and so we've been trying to apply those lessons here. And so going from left to right, we first start with the data sources, which consist, of course, of the robots and the distributed services comprising the fleet management system. We also deployed an intermediary gateway to simplify how robots at different sites connect to our cloud services, making it easier to manage various network setups. If we then move to the data sinks, which is basically AWS S3 and a data management layer over that. Further right, we come to the query and processing tools and the serving layer that will power various data products. We divided the data ingestion pipelines into two channels. So one is used to stream lightweight robot telemetry in real time to our cloud backends for live fleet level observability. The second is used to upload bulk data logs that Ryan mentioned from the robot software in batches. This is high volume, high fidelity data, and not something that we need in real time, and something that we can wait a few minutes for. Both data streams are enriched with context-related metadata tags for data attribution downstream. In addition, telemetry and event data from the various fleet management services also feed into the data platform, and this forms the foundation of our cloud data infrastructure. So we stream the robot telemetry consisting of logs, metrics, and traces to Datadog. To get real-time observability into the state of our fleet. We use open source frameworks like FluentBit for logs and OpenTelemetry for metrics and traces. This gives us optionality with respect to choosing backends and avoids vendor lock-in at this early stage. So for the logging, stream logging, data is buffered in both memory and file system, and we configure it with various back pressure management policies so it can be resilient to bad network conditions. This streaming data channel is for ingesting signals for immediate insights and quick reactions, such as monitoring the health of robot components, system metrics like CPU, file system, things like that. Our robot software also continuously writes data in Avro and another proprietary binary format. And these logs are, these log files are rotated every 5 minutes. Once a file is marked as finished, it's detected by our scanning agent and then fed to a local buffer. And then our ingest agent now steps in, enriches the data with some metadata tags and around the robot serial number, build information, organization, and work cell. And this helps us sort of contextualize the data downstream when we analyze it. This enriched data is uploaded to S3 and then passing through an API gateway. We're also adding a layer of intelligence with our data prioritization system. It's both schedule and bandwidth aware, ensuring that we can efficiently manage data uploads based on the robot's operating environment and available network resources. This approach sort of minimizes bottlenecks and ensures that important data gets uploaded first when bandwidth is limited. So S3 is where we store data for the long term. Our partitioning strategy for routing data to S3 is to use the attached metadata attributes to organize the data, which makes retrieval and analysis more efficient. The data is partitioned based on organization, the log type, whether that's the diagnostics, application logs, planner data, and so on, along with other robot metadata, the date and the hour the data was generated, and the unique run ID associated with the control program. This hierarchical structure allows us to optimize data for querying and retrieval, and reduces overhead when we need to access specific subsets of data. For instance, if you need to review the diagnostics logs for robot number 15, during 2 hours, last afternoon, we can just target that data, avoiding the need to sift through large amounts of unnecessary logs. This strategy also gives us more granular control over the data, enabling us to apply different compliance or data management actions based on the log type or the organizational requirements. Once a file is uploaded to S3, it triggers the AWS Glue Lambda that we have written, which manages the lifecycle of data sets in the cloud. A data set essentially consists of logs from a single log category for a single customer or an organization, divided by run and by hour. Each customer has their own corresponding database and a unique schema registry. Data sets are also indexed with the ingested metadata tags related to the run and work cell context. So we can, it helps for better query performance as well. This data lake lets us explore petabytes of heterogeneous data from across the fleet interactively in SQL using the query engines that connect with Glue, AWS Athena, which is essentially Presto under the hood, Presto or Trino. We can also build complex data pipelines to process the same data for business intelligence, performance analysis, and ML ops. Our goal with the data lake was to sort of democratize access to internal users, whether they're technical or not. As I mentioned before, Datadog is our real-time observability tool where we store and visualize both robot and cloud software telemetry consisting of logs, metrics, and traces. Users can set up dashboards to slice and dice data by individual robot or roll up by work cell, the fleet, or the organization or customer here, using the tags that we set upstream in the pipeline. It's also hooked up to our alerting system, which is PagerDuty, to page us on incidents and anomalies. Now we come to Foxglove. We faced some challenges with our previous setup for data playback. First, we were using a proprietary data format, which limited flexibility and kind of locked us into the in-house visualization tool. This in-house visualizer, while it worked well for many cases, it became clear that maintaining this custom solution was inefficient and was slowing us down, especially as we scaled. So to address these challenges, we decided to migrate to an open format and adopt external tools that are better suited for our needs. Specifically, we moved to using MCAP as our final data format. We still write data in intermediate formats like Avro or JSON and our own binary format, and then recombine as necessary when we want to ingest it into the visualizer. So combining this new accessible format with the data lake and the data catalog, this allows us, the data platform team, to create tooling to enable users to pull whatever playback data from a time frame of interest from a particular robot, visualize it, and then share the analysis.
Right. Yeah, and so coming into this next part is where we start talking about the differentiation of where we had sort of like the traditional robotics tools where you're looking at an individual run, but we wanted to be able to use that same data platform to actually analyze the entire fleet at the same time. And so that's where we end up bringing that same data into tools like SuperSet, which give us like a SQL-like query engine over the top of the data. So then we can see like, what was the charge rate for every robot over the last month? Like, how is it evolving over time? Can I look at an individual robot over the course of several weeks or months? And that's really what these kind of tools allow us to do on top of it. And then it also allows us to do more like business intelligence type things. So it allows us to plug in our program managers and things like that to actually understand how the fleet's doing. And then the next one is probably pretty popular for all of the ML folks, is getting Jupyter Notebooks set up. Because we have all of our data in the cloud, being able to set up Jupyter Notebooks allows us to actually access that data directly instead of having people share Google Drive files or downloading things off the robot directly. Everything's in the cloud, everything's accessible, and it's much easier to just share like a Jupyter script than it is to like send people Python scripts over Slack. And then the last part of our thing is Agility Arc, which is sort of like our overall fleet management program. And this is where we actually end up controlling the rest of the products that you had seen previously. And so this is our single pane of glass that allows all of our users to kind of evaluate the robots themselves and provides access controls around each of the different services. So we don't provide like Foxglove to all of our users. We don't provide SuperSet to all of our users. But with this, we're able to do role-based access controls and really segment out our user base for that. Similarly, it also allows us to do customer separation on our data. And so that way we can make sure that since most of our customers are like big companies, they don't want to see other big companies' data, and they don't want other big companies to see their data. And so we're able to use this to actually do that customer separation while still giving everybody a single application to use.